Okay, today is the 9th of April 2024, and this will be our fourth video on circle theorem. We are going to look at more examples. Okay, if you haven't written down the theorems on your flashcard and you are struggling to use them, I would suggest you copy them out on a flashcard or in a notebook where you normally look at your equations, okay, and your conversions, and then use them, okay, because as you watch them with time, you'll be it will just be a second nature. Okay. Thank you very much to everyone who have subscribed to our channel. Okay, please subscribe, share, like, and follow us. Okay, depending on which platform you are watching from. Please follow my notes/scripts. Okay, I'll always leave that in the comment section, because at times you are trying to video. For instance, this is a equals half AB sine C. If you hear anything else, just follow the notes. Okay, I appreciate that. And please, if the account is not yours, the one that you are going to use to subscribe, ask permission from the account holder. Let them know that you are using the account to subscribe to this platform. If they don't agree, open your own account or ask somebody to help you open your account. Subscribe. When we upload, you get your notification. Okay, beware of scammers, please beware of scammers. Don't be scammed. Watch last video for recap. At this moment, if I want to be recapping and talking about last video, what we did, we don't have that time now. So what is still on circle theorem, we were looking at some interesting questions. Okay, so watch last video for recap. Today I have two starters for you. Okay, and the first one is part of the circle, because we had like 5 days break, so maybe some people have forgotten. And with maths, there's a need to always keep on reminding you, because immediately you stop reminding yourself, basically you forget. Okay, and you don't always have to go and take an exam before you look at maths. You can look at maths with your kids. You can help them out, because maths is very good for your mental health. Okay, at times people ignore that, but it's very good. I think 3 or 2 years ago, there was a senior citizen in the UK, I think 70 plus, who just went to do maths Gcse's. Okay, he didn't get it when he was young, but this time when he went, he got it. Meanwhile, he's, I think, 70s or 80s. He was bored at home. He didn't have anything to do, and then he went to, I think, the adult center, joined there, did it, and he passed, to his amazement. Okay, so please, it's very good for your mental health. If you shouldn't say that, oh, I'm going to do an exam, you can also follow us and just keep your mind working and thinking about stuff. Okay, part of a circle. So I decided to bring this again since we are doing circle theorem, because I'm saying things that people might not understand if you watch the video the first time. Okay, so that is a radius here. I've done a video or part of the circle, so go and look. Okay, so this is one circle. That is the radius from the center to the circumference, that line here. Okay, the chord doesn't go through the center. Okay, the diameter goes. So if I have two radius, then I have a diameter there. So assuming I extend the radius to the other end, then it becomes a diameter. The chord doesn't go through this center, so it divides the circle into a major and a minor segment. Okay, now this is the circumference. So the circumference is like a length. So if, for instance, if you are here and you are in a circular form in real life and you walk around this field, assuming it's a field, and come back to this point, you've just walked the circumference of a circular field. The tangent, if you pick a point on the circumference and you draw a straight line, that is the tangent. Okay, so assuming you pick this point and you draw a straight line through that point, okay, it will form 90 degrees to the tangent. So assuming there is a radius from here to there on that point, that will be 90 degrees there. Okay, so I thought I would just bring these few ones and show you. We have major and minor sector as well. Okay, we have a few things, but for now, today, I just wanted to show you this one. Okay, so even though I've drawn one circle, I didn't want to clutter it, so these are the few ones I want to show you, because this is what I keep on mentioning over and over again. But if you go down our videos, there are videos on parts of the circle that I have drawn a circle and just use one circle to speak about one stuff. Okay, please go back and watch it. Okay, now the second starter we have here, we are going to use the area equals half AB sine C. Okay, you remember this formula. The area of a triangle, please, the area of this shape. Okay, this is the area of a triangle. Okay, so if you have this one triangle, you have half AB sine C, if you know the angle here. Okay, if C is 90 degrees, it's basically 1. So it will be half base times height. So you go back to the standard formula. Okay, but assuming you have this shape here, you can divide it into two triangles and use this formula. Find this area, find that area, and add them together. Okay, now, so we are using half AB sine C. This angle here is 126. That angle here is 89. So what do we do? The first area A, after dividing it, okay, I wasn't given this line. I drew it myself to solve this. Okay, so the area for A is half, okay, 16 times 12 sine of 126, that one here. So if you do that correctly on the calculator, you get it with sine C, okay, you get 77.67. The second one, okay, is half again, 28 times 9 centimeters, sine of 81. Okay, so I've written that one here. So area B is half AB sine C, so half 28 times 9 sine of 81. Again, if you do that one on the calculator, you have 124.5 centimeters. Area is in centimeters squared, okay, because they gave you the length as centimeters. So to find the area of the shape A and B with the full shape, we need to add area A, area B. Area A is 77.67. Area B is 124.45. So you add them together, you get 202.11 centimeters squared to 2 decimal place. Okay, that is 5 significant figures. 202.1 centimeters squared, that is 1 decimal place, or 4 significant figures. 202 centimeters squared, this is the nearest whole number, or 3 significant figures. Okay, so leave your answer the way they asked you to. I decided to put this here because, as we always said and discussed, some of the questions might restrict you. Okay, so these are things we did earlier on to understand what a decimal place is, what a significant places, 2 significant figures, what they are. So if you don't understand, just go back and help yourself. Okay, because it might not be a full question, but assuming they said leave your answer in 3 significant figures, and it is all the nearest whole number. The nearest whole number is easy, okay, or 1 decimal place, and you didn't get that, and you leave your answer as 202.11, you won't get the full marks. And as much as possible, you want to take as many marks with you as possible. Today we'll do more circle theorem. Okay, so the first example I have for you is this diagram here. Okay, that is 30 degrees, that is x, and that is y. Now your question is, it's not to scale. All my diagrams so far not to scale. If it's to scale, I'll tell you. Okay, find x. So that is x here. Okay, if this is 30, one of the theorem, 30 degrees, then x here is also 30 degrees. So this is where I'll say follow my note. So if I say 30, I mean 30 degrees as in angles. Okay, x here is 30 degrees. Always remember your units. Yesterday I said to you, make sure what you are thinking is what you are writing, because the examiner, they don't know you, and you will not be there when they are marking. So what they see is what they mark. So you don't have the opportunity to go and say that, oh, this, they might figure it out, but they can't give you the marks because it's not on your paper. Okay, so make sure what you are thinking and working out is what you write. Okay, because as I said here, that is 30 degrees and x. So if I wrote x is 30, I haven't completed this, is 30 degrees. Now what is y? Okay, we know that this and this angle, or 30 and that angle, if I'm considering this cyclic quadrilateral, should be a cyclic quadrilateral. We've spoken about that. A quadrilateral that fits into a circle. Okay, so now 1, 2, 3, 4, 4 sides. That's the cyclic quadrilateral, and that's also 1, 2, 3, 4. Okay, so if that is 30, that is 30. So this and this angle should be equal to 180. So if this is 30, then that is 150, and that will be 30. So x is 30 degrees, y is 150 degrees. Okay, so that will be our first example. Our second example now, okay, here, okay, is this shape here. Okay, it looks like a cone, but it's not. It's a circle, and it has two tangents. Okay, and it has two radii. That is a radius AB, and BC is also a radius. Okay, and you have a line from B to where the tangent meets. Okay, now, and that point is D there. So you have D, A on the circumference, B the center, C on the circumference, and it makes a tangent. Okay, now one of the theorems is AD will be equal to CD. Okay, so now the question says why would ABC equal 120? So here we are not supposed to say D is that, but they say why would it be? So they've given us, so why would ABC, so this is ABC, the full angle here. Okay, if this is 30, because this and this are the same, that will also be 30. Okay, and what we did earlier on, if that is 60, then that will be 120, the full angle at B, not just half. Okay, because that will be 90 here, that will be 90 there. Okay, so that will be 60, that will be 60. So you can explain that. So I said opposite angles add up to 180. So angle at D will be 60. This full angle, not just the half. It will be 30 times 260. And then therefore the angle at ABC will be equal to 180 minus 60, which is 120, that angle here, the full angle. Okay, not just, if they say ABD, then that will be 60, but ABC, these two angles here together, okay, because this tangent and this tangent, because they intersect, they have the same length. It's one of the theorems. Please, if you don't get it, put it on your flashcard. Okay, especially if you are going to write an assignment, put it on your flashcard. Watch one a day. Okay, use it to solve questions, because these questions are easy to get marks on with little calculator knowledge, and normally these questions come in the non-calculator paper, so you should be able to get it right. Okay, now there's another question here, and all my diagrams, as I said, is not to scale. If I haven't said it, it's still not to scale. If it's to scale, I'll tell you and I'll give you the scale, or I'll tell you how I measured it, but these angles are not to scale. So again, PQ is a tangent. Okay, so that was the reason why I had to do the starter today, to show you, because I'm using terms, and because we've done the video a long time, maybe some of you might not get it. OP is a radius. Okay, now OQ is an extension of the radius to cut the tangent here. PQ here is 7 centimeters. Okay, let's look at the equation. So I've just explained the diagram, part of the question. Okay, now PQ here is 7 centimeters. Okay, so it says the area of the triangle is OPQ is 21. That one. The angle we have is 90 degrees, so sine of 90 will give us 1. So we can basically use half base times height. Okay, so this area here is 21 centimeters, will be equal to half the base, which is 7, times height. The height OP here is the radius. Is that okay? So if we use that formula accurately, we are going to get 21 being the area, half the base times height, which is the radius. If we find that radius, then we can put that radius and find the area, because we have been asked to find the area of the circle. It says calculate the area of the circle, that circle here. Okay, so now 21, if we bring 2 to this side, we have 42. 7 is multiplying here, so if it comes here, it is going to divide. So we have 42 over 7, which will be equal to h. So h is 6 centimeters. So the radius, which is the same as the height of the triangle, is 6 centimeters. Okay, so now the area of the triangle OPQ, so we are there. So we have just found the radius, which is 6 centimeters. Now that we know the radius, we are finding the area. Okay, even if they ask us to find the circumference, we still need the radius. That will be 2 pi r. But now the area of the circle is pi r squared. So pi is a constant, which we might get on our calculator, and then r is 6 all squared. If they ask us to leave our answer in pi, then it will be a non-calculator paper. But assuming they ask us to, we can use 22 over 7, okay, or 3.142, or we can use a calculator to give the answer if we have a calculator and it is allowed. So pi r squared, so pi r, which is the radius we found, is 6 all squared. So 6 all squared is 36 pi. Okay, we have 7 centimeters here. Okay, so the unit of the circle will be pi, 36 pi centimeters squared if you are supposed to leave an answer in pi. But if you are not leaving an answer in pi and we have the calculator, then to one decimal place is 113.1 centimeters squared. Okay. To the nearest whole number, it will be 113 centimeters squared. Okay. So that will be our answer there. Okay. So I have given you a starter today that shows you the part of the circle. We've used a area equals half AB sine C. Okay, we did a video on that when we're doing trig. Okay, so you can have a trig question and a circle theorem question merged together. Okay, so you can use that to find the area, assuming this wasn't 90 and it was a different angle, then you have to use half AB sine C. Immediately you do that, you can get your height and then you use that as your radius, assuming the radius is from there to there. Okay, and this didn't have to, assuming the area was that way. Okay, and you know this you know this angle, and then you can use that as your radius to find, okay, to find the area. So they can give you a lot of things. They can give you two questions together. So first of all, understand the question, know what you are being asked to do, and then just do it. Because if you break it, maths is like a jigsaw. If you can analyze the question, then you can solve it and get your marks. Okay, so this is what I have for you today. Okay, if our platform is helping you, share, like, nice comments, subscribe, follow, do whatever you can to help us circulate. Okay, so that a lot of people, because around this time a lot of people need it anyway. And then please follow my notes scripts. Okay, if I'm talking about angles and I say 30, please add the degrees because it will be in the notes. Okay, and when you are answering the questions, follow the rules. For instance, I didn't put anything here because maybe the original question said to the nearest whole number. I didn't, because maybe you might see the question somewhere and you think, oh, it was 113. And then you quickly do that without reading the last part, because even though, and then you end up getting it wrong, they might ask you another time the same figures, leave them answer in pi. Okay, so at times I try to bring the different answers they can give you and show you. Okay, because I think we've done this earlier on. So at this stage, if you've been with me since we began, or you've been watching the videos, you understand these things by now. Okay, so follow the notes, please, and beware of scammers. Take care of yourself online. Thank you very much for watching today's video with me, and I'll see you in the next.